Hello and welcome to the video on stacks. We're going to see what stacks are, where they can be used, how they can be represented, and also some actual code for performing operations on stacks. So, stacks are a linear type of data structure, basically a collection of elements of the same data type, and stacks have two operations in their most basic form, push and pop. Push to insert an element into the stack, and pop to take an element out of the stack, or take out the last element from the stack. A real-world example of a stack is the pile of plates in your kitchen sink that you're going to have to wash after dinner. And another common example is that of the chair. You know, everyone has it. That's also a great example to explain the stack concept. An example in the software world would be that of recent searches. Whatever you search the most recently will be visible at the top. And you might have noticed that the stack is a LIFO or LIFO or philo structure, meaning last in, first out, or first in, last out. Basically, this means whatever goes in first comes out the last, or whatever goes in last comes out first. Yeah, I totally agree that the chair can be an exception to this, since whatever goes in might not even come out. And you might have noticed in the pile of plates in your kitchen sink, whichever plate goes in first gets washed last, and whatever dish is put last on top of the stack is washed first. Now, a visual representation of a stack that we'll be coding up can be something like this. As you can figure out, only one side is open, so things come in and go out from the same end. And of course, whatever goes in first comes out last, and whatever goes in last comes out first. Now, let us look at terms that are associated with stacks. On the left side, we have some functions which are mostly used in stacks. And on the right, there are just two terms which can be used with stacks. So on the left side first, we have a push function, which is used to insert an element into the stack. Then we have a pop function, which is used to remove the topmost element from the stack. Basically, the element that is pushed in last is popped out first. And the element that gets pushed in first is popped out last. Push and pop are two of the most important functions of the stack, but the next two functions are also used many a times. The top function is used to return the topmost element, and the isEmpty function is just as the name suggests. It's used to check if the stack is empty. On the right side, we have two terms, stack overflow and stack underflow. Stack overflow is a condition that arises when you try to push an element into a stack that has reached its full capacity. And stack underflow, as you might guess, is the condition that arises when you try to pop an element from an empty stack. So that when there is no element and you try to pop an element, that's underflow. And that when the stack is full, you try to push an element which can't fit in there. That's called this overflow condition. Okay, now that we've seen stuff about stacks, let's dive into some actual code. And yeah, there can be two ways in which you can implement stacks. One is using arrays, and the second is using linked lists. We're going to be implementing stacks using arrays. Okay, so we're in the code blocks, and we're going to look at some actual code for implementing stacks in C++. So first, we have a class stacks, in which we have a private member int top, which is going to store the position of the topmost element of our stack. Then we have some public functions and elements here. First, we have a stack array, which is of type integer, since we want to store a stack of integers. And we've defined the size as max, and max is defined as 5 over here. So our limit to our stack is 5. So our stack cannot exceed 5 elements. The max number of elements it can contain is 5. Then we have a void push, which is a function to push elements into the stack. And we've provided a parameter, or we've provided the data type, which is int, So we're going to push integers into the stack. Next, we have a int pop function to pop the last element of the stack. And of course, it's going to return an integer since the data type of the function is int. And then last up, we have a void display to display the elements of the stack. Also, we have a constructor for initializing the topmost position or position of the topmost element to -1. Now let's take a look at the actual functions of our stack. First up, we have a push function here in which we're going to push integer x, whatever the parameter is, into the stack. So first, we're going to check if our stack has number of elements greater than 5. And as we see in the terms section, that is going to be an overflow condition. So we're going to display the same message accordingly. Otherwise, if there's space left for any element in the stack, we're going to insert the element into the stack. So basically, our numbers array, and we're going to increment the top position, or position of the topmost element, and we're going to equate it to x, which is our integer that we want to push. And then we're going to display a message saying the inserted element is whatever the number is. Now let's take a look at the pop function to pop an element from the stack. We're going to check if it's stack underflow condition, and that means that there is no element that we can pop, and basically the stack is empty. So this if statement is going to check that, and it's going to display a message accordingly. Otherwise, if there aren't any elements to pop, we're going to assign the number, or we're going to assign the last number to an integer d, and we're going to see out a message saying this is the popped element, and we're going to return d. Since the data type is int, it's going to return the integer that we have popped out from the stack. And last up, we have a display function. This is going to check again if the stack is empty and display a message accordingly. And otherwise, it's going to display the elements of a stack like we would for a normal array. But the condition here is that we're going to initialize, or iteration variable, we're going to initialize the topmost position. Is going to go up to 0, and then after every iteration, I will be decremented by 1. And then cout statement is going to display whatever element is in the stack. And of course, after the for loop is complete, we're going to display a end of line. Okay, now we check the functions. Let's check our main, or int main. We created an object of the stacks class, and then using a do while loop, we're going to ask the user to input a option from this. So I've just said 1 to push, 2 to pop, 3 to display, and 4 to exit. You can do it any way you like. Case 1 is basically pushing the element into the stack, and we're going to take input from the user over here, whatever number he wants to input or push into the stack, and then we're going to use that as a parameter for the push function over here. Case 2 is pop, case 3 is display, and case 4 is, of course, end of program. And then default, we have a invalid input statement. And we're going to continue until choice doesn't equal to 4. So we've seen the basic code. Now let's see how it can get implemented. All right, this is our console. It's asking us, as we expected, 1 to push, 2 to pop, 3 to display, and 4 to exit. Now let's try stack underflow condition first when we want to pop an element that's not there. It's not going to work, and of course, it's displaying stack underflow condition over here. Now let's try to display the stack in which we have no elements. Again, it's going to display that stack is empty because, of course, the stack is empty. Now let's push an element into the stack. Let's say 3. As you can see, it shows us that 3 has been inserted into the stack. Let's push one more element. 5. Push one more. 10. Now let's display the elements, if it's correctly displayed or not. As you can see, we have these elements displayed in the proper order, and 10 is at the top since we pushed 10 last. And that's the first element that's going to be popped. So let's try to pop an element now. As you can see, the popped element was 10. Now let's display the stack again. Yep, 10 has been popped. And as you can see, it works properly. So yeah, that's a way to implement stacks. So yeah, that was a basic introduction to stacks. And let me know how you felt the video was in the comment section below. And thanks for watching.